Bismillahirrahmanirrahim. Assalamu alaikum, viewers. Today's topic is using the solver to minimize the cost and optimizing your solution to come up with this cost which is minimum. This is um, a frequently encountered situation for any manager, and uh, having the Excel skills, he can um, best utilize it and come up with an efficient solution for his process and uh, for the betterment of the company he's working for. Okay, so the Excel has the solver, which is a very multi-purpose and very efficient, and it can you can use it in numerous ways to or come up with a uh, optimum solution for a given situation. Okay, so today's topic is for minimization of the cost, right? For example, you have the assignment that you have to purchase 500 kg of the rice. That is for sure. Okay. This is a given quantity that your requirement is the rice of 500 kg to be purchased uh, from the market. Okay. And when you study the power market, you see that there are different packaging available with different prices. Mm. And the rule in the market is, which is governing this uh, mm, share and purchase is that the higher is the packaging, the more is the discounted price, right? So, for example, the half kg, yeah, this is the half kg packing of the rice comes for $0.5. Okay, so we make it, for example, here the dollar. Mm, okay, sorry. Mm, yeah, this is in the price is in the dollar, right? And one, so then you have this set. The the noticeable fact here is that the manager, being a manager, you should should be knowing the basics of tabulating the things, the spreadsheet working, column and row setting, and to come up to tabulated solution, right? That is always good and controllable and manageable and will make sense uh, and will have a greater readability. So first of all, you have to decide that what columns uh, uh, are are necessary in your situation. First is the packaging available, the half kg, 1 kg, 4 kg, 7 kg. So the first column is the packagings which are available, right? The second column is going to be the price. So each packaging has a different price, and you see there are certain. Mostly it is that the higher is the size, the greater discount you have, right? The here the the half kg was $0.5, and the 10 kg by that rule it should be $5, but it is even less than in $4.65. So you are having the discount like this. Okay. The next is the quantity. This is the quantity is actually uh, this will be the input. The solver is going to use it to keep on changing it, and seeing and that which is the most feasible solution with the minimized cost, right? So in the beginning we keep it as one all. Okay, fair enough. The next is when you have the price and quantity, then you need the row-wise weightage, right? The weight. Weight is if this is a half kg times the quantity, this half kg. If uh, it is 1 kg and you have one quantity, then it's 1 kg, right? Similarly, it's 4 kg. So mm, as soon as you have the quantities here, this will of course not remain the same. Rather, it will be multiplied by 8. So multiply this with this. Okay. So this is the multiplication of the weight, and we have the target day. So this is going to be to play as a constraint for us that this total amount should not exceed 5 or 500. Okay, so fair enough. The next is the cost. The cost is uh, simply the multiplication of what this the and quantity and the price, right? So this is going to be the cost. So here also, this is our our objective. The main objective is to minimize this cost, right? Minimize this cost. Okay. So we are now prepared. We what we wanted is we have the objective. We have the total quantity of rice which we want. Uh, it has to be, and it has uh, uh, to be run. Means we have to run the solver with the minimize option so that this cost is minimum possible. And our target is that this amount reaches the 500 kg, right? We have 500 kg rice with the minimum cost available in here. Okay, so by changing all these things, so we have everything here. So now we can quickly go to the data and go to the solver. And for the first thing you specify is determine what is your objective. Our objective is G12. Because we are we want the minimum optimize cost, right, to be here, right? And so we want this to be minimized. We want G12 to be minimized. That's it. Okay. And then we are going to uh, tell that what is the range in which we will be changing. We will be changing this. Okay. How many quantity? Only change the quantity and get the result. That's okay. Now there are certain constraints here, or only two constraints here. The first thing is that this quantity which we are using, it should not be other than the whole number. So it has to be integer, right? So for this you specify that this is equal to integer. Okay, so that's right. And the other thing is that it is greater than or equal to this, because due to packages, it may exceed something 510, 514. That's not, we don't mind as long as we have the optimum cost solution is here. Okay, so we are going to specify another constraint, that is this total of the weight is greater than or equal to 500. Okay, so that's it. Now let's clear, do put a tick mark here because that will tell the solver not to go to the minus sign. No negative quantities permit, permitted in here, right? Another thing is that the fastest solution in our case is the simplex LP, linear programming, right? So we click OK here, close, means we run it. So it has come up with the solution that the best you the 500 kg has been achieved with mm, the optimum cost, that is 2183. Any other combination will be will be higher than this. So the computer is suggesting that you buy 125 bags of 4 kg each to get the 500 weight with the lowest cost, that is $218.75. So this is how you use the minimum minimization of your cost. And this is a simple example, but you can develop a more complex and more that would be, if done manually, it is going to be very time consuming, and there are chances that you may commit mistakes or come up with an erroneous solution. So the solver saves your risk and saves your time and come up with the optimum solution. Thank you very much.